Hello, this is Ryan for the assignment 1 of machine learning. So we have 21 questions. So first of all, I import the dataset for fashion MNIST, and I try to load the dataset using train images and train labels. And we also have the datasets also have the test images and test label as well. So these are the label that I can summarize from the datasets that have 9 labels. And these are the contents of the image, which is the name of the clothes inside the image. And then I try to print the shape of the dataset to see the dimensions of train images, train labels, and test images as well. So in the training set, we have 6,000 images. And then in the test set, we have 10,000 images and 28 by 28 pixels for each image. And we can see so the length of trains labels are 6,000 as well, and then the length of the test label are 10,000 as well, which is accordingly matching for the test images and training images. And then I'm trying to show some of the train and test labels, so we can see that the number vary from 0 to 1 to 9 actually, 0 to 9. So we can try to show the digital content of the image number 5 in the dataset. So we try to use the training datasets using the number 5 content, and it is like this. And then when we try to use the plot the image using the mshow function, with the color bar as well, and we can see that the images look like this, and which is the I guess this is a pull over or a sweeter. And then we try to print the appropriate training labels for the index number 5, and we can see that the index was 2, which is the pull over. And after that, I try to show the digital content of the image index number 500 of the test images. And then we can see we use the print function, and it's gonna be like this with 28 by 28 pixels, and also try to plot the image by image of index 500 as well in the testing dataset, and we can see this one as well, and it properly the pull over as well. And then we try to print the label for that, which is number 2. And so the dataset is mostly legit when we cross validate it. And then as the instructions, I try to import the model and the layers from the Keras library and try to build a neural network with layers of neuron. And first of all, we add reshape the image from 28 to 28 by flatten it to one columns with 784, which is using it to reshape it. And then when I try to reshape the image, and then I also try to add a hidden layer that have 128 neurons, and using the ReLU activation function as well. So we have the functions that add and then add the dense layer of 128 neurons and using the activations of ReLU. And then after that, we have to add also add the dense layer of 512 neurons as well, and then with the reload function as well, and then 255 for this as well. So in total we have 3 hidden layers, and the last layer with 10 neurons with the submark activation. So the reason why we use the submark is that we use the output layer for classification model. So the goal is to predict the probabilities of n multiple exclusive classes. So the submark ensure that the output value is ranged between 0 and 1, and because we want to see the probability output, so we make sure that it can be interpretable as the probabilities. And it's also well suited for the classification task where an input belongs to only one class. So like yeah, probably our inputs only belong to either 1 to 10 classes. So there's nothing in between. So we have to make sure that it is either between 0 or 9. There's nothing like in the middle. They cannot belong to two classes. And then for so I create with for the requirement to do the options A and B for different setting for compile. So I try to create the model again using my network 8, and then compile it with the Adam optimizer, and the last we use the Spark categorical cross entropy. And then we use the metric as accuracy as well. And for similarly, we do the option B. We compile with the optimizer is RMS probability, and the loss is categorical cross entropy, which is compared to the other one is par categorical cross entropy. So first of all, we try to print the shape of the training set and the labels again to see if it is right for our data. And then after the compilations, we try to find a pattern using the fit common, which is trying to see with the number of airports is 10. As we can see, after the 10 layers of airports, it will be like this, and we can see the value of loss and value of accuracy as well. So as you can see for the option B, so the only difference is that option A and option B. Option A we can use the flattened images and the labels, but for option B we need to use one hot encoded because of the setting is different, which is for categorical cross entropy, and the model B we only use the categorical cross entropy. So we actually need to be the label need to be hot one hot encoded. So so that because of the option A model, the labels can be remains as the integers, but because of the different setting, so we have to change the label of the training set and testing set to the categorical first before we can do the model compiler and fit. So we do the fit functions on that using the encoded labels and the encoded training labels and encoded test label. And after that, we can see another 10 airports as well, but the accuracy is decreasing and the value of loss is increasing as well. So we can see at first it is 82%, but after that it is 63% at the final airport. So first of all, to compare about the fashion minutes and what we learned in class using the minutes for writing, handwriting, we can see that Miss and Fashion Smith both datasets consist of 28 by 28 pixel grayscale images with 10 different classes. And so one is the number 0 to 9, and the other one is 10 different type of tops. And the minutes contains handwriting digits, as you can see, and the other one is like t-shirt, trousers, sneaker. Both of the data set are split into training set, which is 6,000. I'm sorry, 60,000 training images, and the test sets were 10,000 images and 10,000 labels accordingly. So, also the difference is that MNIST is a classic problem where the goal is to classify the handwriting digits, which are simpler and have the less varied than the type of images in the fashion dataset, because fashion dataset provide a much more complex and a little bit more realistic images of the fashion items, would are more challenging to for the model to distinguish or to tell the differences. And the diversity in shapes and textures and the styles requires the model to learn more of the intricate patterns. So, what we can find the difference in Model 8 and Model B with different setting. So, we can see that Model A's have higher accuracy at the end of the model, which is 0.8 489, and Model B, actually the Model B's the accuracies now is 0.6 at the end, which is 0.6392. Okay, so it is 60% correct for the classifications, and for the classifications of Model 8 after all the efforts, the accuracies is 84.89%, which is pretty high, suggests that it generalized well to the new data. It achieves a balanced performance with both high test accuracies and low test loss as well. And we can see above and indicate that it has learned the meaningful features from the data without overfitting. And for Model B, it is struggle to generalize to the test data because it perform is poor, and both of the term of accuracies and the loss is accuracy is slow and losses tend to be high because they might have some overfitted to the training data and fail to learn the generalized features. And the reason for that, it could be because of the reason for that it could be because of the maybe because of the model architectures and hyperparameters. So maybe for Model A, we use the Spark we use the Spark categorical cross entropy, and for Model B, we use the only categorical cross entropy. That is a different that it can explain why there is a different or there is a different accuracy as well. So as we can see here, when we use the evaluate functions, we can see that um, both of the model B has the accuracies of 0.6392, and the loss of the Model B is pretty high, which is 1.9. And for Model A, we have 0.8688, and the loss of the model is only 0.3946. So let me fix it here right now. It was from the previous running, and then as was well, maybe this to the random things. Okay, it should be working. Okay, and then another reason for this difference maybe because of the class imbalance or the label issue as well. So both of the model has balance in terms of classification distribution, and maybe there's some small fluctuations in class distributions that can impact the accuracy, and also when the data set become more complex, the model may perform works for certain classes. That could be the reason. And also another reason is maybe for the learning curves in the airport as well. So both of the model have different setting, and also like the fashion smith slower increase accuracy during the early export might indicate that the model is a little bit struggling to extract the meaningful features from the image as well. And in that case, yeah. Okay, and we can see that the last questions is we have the evaluations of the two model. So we can see that model A is higher with accuracy and no overfitting, and model B we have a lower accuracy and with a very high loss, and this seems like to have the overfitting. And that's it for this assignment. And thank you so much.